Alright, let's solve another problem related to Kirchhoff's law. This time it is question 115. We're given a diagram. It is quite a complex one. We have 2 power source and 5 resistor. The first power source over here has a voltage of 18 volt. And we're going to add the plus minus. We got this one, 45 volt. Alright, now one of the things we should do right at the beginning is write the plus or minus of each resistor. On which side of the resistor is the voltage higher? You will see for the loop rule, this can be very helpful. As I seen in the previous year, determining which side of the resistor has the highest voltage is a common mistake. So let's look at R1. We got I1 is going that direction. Now, by the way, we are suggested strongly to follow that the current R1 is going to the left, so in this branch. I2 is going up in this branch over here, and I3 is going in this branch over here, all right? So we're going to keep the same notation, and it's possible that one of them is wrong, but we will know at the end, and it will not influence our answer. Now, if the current is going in that direction, the charge are coming in, they always have a higher energy before entering the resistance. So in R1, this side is higher, has a higher voltage. Let's look at I3. So the current is going that direction, which means that plus, minus, and this one is following the same logic. Here we have I2, so we got a plus and a minus over here. Same logic over here, plus, minus. All right. We are going to first write down the junction rule. So the junction rule state that all the current coming in has to equal the current coming out. If we look here, I1 is coming in. All right, so let's just write junction rule. We got I1 is equal to the current coming out, which is I2 plus I3. So I1 is equal to I2 plus I3. Now note, one of the goals of Kirchhoff's law is to solve for the current. In the previous example, we had only one current, so using the loop rule, we were able to find the current. Here, we got 3 different current. We got that formula, and we need to use the loop rule to be able to substitute some of the value here and work our way until we can isolate one of the variable, solve for one, solve for the other after. All right? So that's the junction rule. We are going to create 2 loops. And my first loop is going to be, I'm going to call it L1. And I'm going to create another loop. And by the way, I tend to follow the current. So this one is going in that direction. I feel that it is more natural. So L1 will go clockwise. But for L2, I'm going to go counterclockwise. I think it's more natural. And it make it easier to not make a mistake. All right? In my opinion. So L1, what will be the formula for L1? Well, it is this loop. Let's say we're going to start at this corner. So at the junction. So we got a voltage drop. It is the voltage drop of R2. Note, R2 is 2.5. So I'm going to write minus I2 multiplied by 2.5. All right. Now we go through that power source. There's a voltage gain of 18 volts, so plus 18. And following the same logic, so minus I2 multiplied by 0.5. We go over here, and there's a voltage drop, but be careful here. This is not I2 anymore, it is I1, so minus 6I1 in this case. Now note, just to simplify our calculation, this one is I2, this one is also I2. Let's replace these 2 terms. It will be easier to write that way. So 18 minus 3RA2 minus 6I1. All right, and it's a loop, so it has to equal 0. All right. Let's do the second loop now. So again, might as well start at the junction. So we go down, we go through this power supply, and note this is the negative side, positive side. So we have a voltage gain. It is 45. And we have 3 voltage drop with different current here. So we got minus 0.5 I3 minus 1.5 I3. We're going again in that direction. Minus 6 I1 equal 0 in this case. So again, I'm going to erase these two terms, simply combine them together. I think it's more natural. So minus 2i3 and minus 6i1, it is equal to 0 in this case. Now, we need to isolate one of the variable, and generally it is easier to isolate one variable that is present in the 3 formula. If we look, we got I1, I2, I3. So in this one, all 3 of them are present. In L1, I1 and I2 are present. In L2, I3 and R1 are present. So only I1 is present in all the formula in this case. So that means we want to isolate I2 with respect to I1, I3 with respect to I1. All right, and the goal will be to replace the term with respect to I1 in this one, and the term with respect to I2 with respect to I1 in that one. So we end up with one formula, one unknown, so we can solve that one. All right, so let's just take that one. We got I2. It's 18 minus 6i1 divided by 3. So that's the formula here if we isolate I2. Let's do the same thing for this formula. So we got 45 minus 6i1 divided by 2 is equal to I3. All right, we take this for these two terms and put it here. So we got I1 is equal to 18 minus 6 I1 divided by 3 plus 45 minus 6 I1 divided by 2. All right, now we want to isolate the I1. I'm not gonna do this algebra. It's it will take some time. So let's jump straight to the answer. It is 4.75 amp. All right, now we got one of our value. We know that these two are equal to 4.75. Well, since we got this value now, and I'm gonna erase the bottom part because we need to do some calculation over here. Well, actually, not really. Let's just erase that part here. So we got our I1. And this formula, basically, if we go to our I1, we can easily find I2 and I3. That's exactly what we're going to do. So I2 is equal to minus 3.5 amp. I3 is equal to 8.25 amp. All right. So what does this mean, the minus? It means that our initial assumption about the current is wrong. It means that I2 is in fact pointing downward. All right? So again, it does not influence our answer at all. It just means that our original assumption is right. So is wrong, sorry. So you need to stick with your assumption until you know the true answer. All right? So in this case, we just found that I2 is equal to minus 3.5 amp, I3 is equal to 8.25 amp, and I1 is equal to 4.75 amp. We just solve our problem here, okay? So it can get quite complex. We got many formula. There's a couple of tricks here. Like I said, I like to follow the current with my loop. It's easier that way. Now note there's a third loop here. We did not use it, but you could use all the resistance around that still work. There's no problem there. The other trick is when you are you have your formula, try to use the variable that is common in all three and isolate the other one with respect to that one. So what we did here is basically, we know that I1 is common in all three. We isolate I2 with respect to I1, I3 with respect to I1, take all these values, plug it back in the first one. All right? By the way, often it is the junction rule that will contain all the variables. So it's often the last formula where we plug everything back. All right. One last thing I want to talk about in the test. In the next question, we will be solving a 3-loop question. You will see it takes some time to solve a 3-loop question. So that means in the test, you will get a Kirchhoff law question for sure. but it will be only 2 loop. 1 loop is too easy, 3 take too much time. The sweet spot is 2 loop. All right, so that's it for question 115. Let's move on to the last example with regarding this chapter.